The last two shapes we're going to graph together are the tangent and the cotangent graphs. So there are two good things to remember when you're drawing these. If you know the tangent values, you'll be in pretty good shape for this, and I'll show the unit circle in a second. You might want to have it handy. Or you can instead focus on the sine and the cosine values to determine where your intercepts are and where your asymptotes are. Because remember, tangent is defined as sine divided by cosine. So if you know when the numerator is equal to 0, those will be where your x-intercepts occur. And if you know when cosine of x is equal to 0, those will be the undefined values, so those create the vertical asymptotes. You can have 0 in the numerator of a fraction, but you can't have 0 in the denominator. And the other important difference to note from this graph to the other two, because it does look very different than the sine and cosine ones, is that our period is no longer 2 pi divided by b, it's just pi divided by b. It's half as wide. So in general, you're going to see the graph repeat its pattern in half the distance that the sine and cosine graphs do. So what I told you in the last slide is that wherever sine is equal to 0, those will be your x-intercepts. And remember, sine is based on the y-coordinate. So since there's a 0 here, one of our locations is at 0 radians, and the other location that has a y-coordinate of 0 is over here, so at pi radians. And then I don't have the rest of the unit circle shown, but hopefully you can extend these concepts into the third and fourth quadrants as well. So those are going to be your x-intercepts. Now, the values where cosine is 0, I told you will create the asymptotes. And cosine is based on the x-coordinate. So if you look up here, here's the only place that has an x-coordinate of 0 that I'm showing, but there is another one at 3 pi over 2 underneath as well. So those will create the intercepts. Now I also have the tangent values listed on here, so it's worth pointing out the tangent values to focus on are basically the ones that have 0, 1, or undefined values. So now I know to put an intercept at an angle of 0, I know to put a height of 1 at pi over 4, I know to put an asymptote at pi over 2, and then just keep going. So over here, it's going to have -1 for 3 pi over 4, and then it's going to go back to 0 for pi. So let's see how that applies to the graph. So first I'm going to mark all of the angles where sine of x equals 0, and those I'm going to mark as the x-intercepts on my graph. So from the unit circle, I just showed you that sine of x hits 0 at 0 radians, pi, and if you kept going around, it would actually occur again at 2 pi if you completed the revolution around. And you can see that it's happening every other tick mark according to the scale I've set here, where 2 tick marks is pi over 2, so 4 is pi. So it's also going to happen again in this direction, 2 more tick marks, and again in 2 more tick marks. Next, I'm going to mark where cosine of x is equal to 0 to indicate the asymptotes. So if you're looking at the unit circle and where your x-coordinate is equal to 0, that'll create a vertical asymptote at pi over 2, and another one at 3 pi over 2, and at these same regular intervals. Again, every other tick mark. So if I go in this direction, this one should be another asymptote for negative pi over 2, or for negative 3 pi over 2. That's usually enough to draw the sketch of our graph, but I will show you again from the unit circle how we can fill in a couple more points here. So we've already done where tangent is equal to 0 and where tangent makes an asymptote, but I also like to plot where does tangent equal 1 or -1 to give me a little bit more of the shape for the graph. So for pi over 4, I'm going to mark a height of 1, and for 3 pi over 4, I'm going to mark a height of -1. So here is pi over 4. If 2 tick marks is pi over 2, then pi over 4 is half of that. And I'm going to mark a height of 1. And then I also showed you that for 3 pi over 4, which would be this tick mark, that one hits a height of -1. And if you kept extending the pattern, you would see that there's another one here. And if I was going in the opposite direction, this makes a -1 here. So you end up with a graph that looks very similar to the x cubed shape. And then basically the same image just gets repeated over and over and over again. So right here, between any of your asymptotes, that's one full period of the graph, because that's one full cycle of the image. And then here's another full cycle of the image. So you can tell that this graph is not as wide, it's not as long horizontally to get a repeated image. So as long as you know your intercepts, then the height of one point should be halfway between that and your asymptote. And so usually I only need you to fill in 2 periods of the graph. I've filled in a lot more here. That's just because I had plenty of space on my grid. Something else that will help you in comparing the tangent and the cotangent graphs is to make sure you focus on the fact that tangent passes through the origin here at 0, 0, and then on the positive side it goes up, and on the negative radian measurement it goes down. The cotangent graph will look very similar to this, but it's going to be shifted over and upside down. So tangent passes through the origin. So again, I've set up my scale, and you'll notice that our rules for cotangent are very similar to what I just showed you for tangent. The period is still a length of pi over b, so these graphs should have the same width. However, they will be shifted over a little bit from each other. They will have asymptotes and intercepts in the reversed locations. And the reason that happens is because cotangent is the reciprocal of tangent. So now cosine goes on top, which means wherever the x-coordinate is 0, that will now be an x-intercept of the graph. And sine is in the denominator, so whenever sine is 0, or the y-coordinate on the unit circle is 0, those will now create the asymptotes because you can't divide by 0. So I'm going to mark in the same way that I did on the last one, but I'm marking different numbers for the intercepts and the asymptotes, basically. So I'm going to start with the asymptotes here. If you look at the y-coordinates on your unit circle, we have a 0 value at an angle of 0, and then another one at pi, and another one would happen at 2 pi. And you could also go in this direction, so negative pi and negative 2 pi. The places where the cosine values equal 0, or the x-coordinates on the unit circle are 0, those are now the x-intercepts of the graph. So that happens at pi over 2 and negative pi over 2. And basically it just happens halfway in between all of the intercepts we just drew. So I can just go ahead and fill all of those in. And the other slight change is that the shape of the graph will now be flipped. So while the tangent graph went up on the right-hand side of the intercept and then down on the left-hand side, this is going to reverse that around and go up on the left-hand side, but down on the right-hand side of your intercepts. So now I can just connect those points that are hitting at a height of 1 and negative 1, and that's one full period of the graph. So I'm just going to repeat that process a couple times here. Again, I'm hitting heights of 1 and negative 1. And that's 2 full periods, which is usually enough for me to give you credit. That's usually all I will ask for on the graph. You can fill in more if you want to. But again, notice that for the cotangent graph, now our asymptote is actually passing through 0, 0. So tangent has the intercept at 0, 0. Cotangent has the asymptote passing through 0, 0. And then the graph is on the 2 sides of that y-axis. So now let's do one last example with some of the transformations being applied to our tangent and cotangent images. This time, we're going to be vertically stretching the graph by 2, so I need to be doubling the heights that points usually land on. And then this means I'm going to be moving the points to the right pi over 2. That will affect both the asymptotes and the points on my graph. So comparing this image to the original tangent graph that we looked at, we said that normal tangent has asymptotes passing through negative pi over 2 and pi over 2, and then it has the dot at the origin. But I'm going to be moving all of these things to the right pi over 2, so I'm going to start off with the asymptotes. The asymptote that used to be at pi over 2 will move to the right 2 tick marks, because that's a length of pi over 2 on my scale here. So I will end up with an asymptote here instead. And then the asymptote that would have been at negative pi over 2 needs to move to the right that same length, 2 tick marks. So now it's going to end up over here. So it kind of ends up looking like the cotangent graph in some ways, because now my asymptote is passing through the y-axis. And then if I keep continuing that pattern, now that I see that there are 4 of these little squares between my asymptotes, I can do the same thing on this side. And I could keep going, but 2 periods is enough for the graphing purposes for the most part. Next, we have to remember that there's a vertical stretch by a factor of 2. So for the y-coordinates that dictate the actual shape of the tangent graph, I need to double all of the heights. Now remember that the intercept will always happen halfway between your asymptotes. So if I have an asymptote here and an asymptote here, then I know there's going to be an intercept here. And that's a y-coordinate of 0. Multiplying it by 2 is still 0. And I'll do the same thing for this one as well. Now the other points of interest are going to be halfway between your intercept and your asymptote. Usually that point is at a height of 1, but I'm doubling those heights. I'm multiplying the height by 2, so it's going to end up way up here at a height of 2 instead. And the one that would have been at negative 1 will now be at negative 2 on that left-hand side. So it's not going to cause a huge difference on the shape, that vertical stretch part. It's pretty minimal change really. But shifting things to the left or to the right had a much bigger impact because now my asymptotes and everything have moved over. And then if I copy this image over, again, I should be hitting a height of 2 and a height of -2. So it kind of swoops out and down. And there we have our 2 full periods. You can fill in more if you want, but for the notes purposes, to keep it shorter, I'm just going to stop right there, and that's it for the notes today.